Hi, my name is Amon.
I'm Stephanie.
And I'm Kevin. Today we're going to discuss the life cycle of food. Have you ever wondered about the science of cooking?
How can you make something completely different, like flour and oil, and get a cake?
Today we'll be answering some of those kind of questions by taking a look at how to make our favorite food, ice cream.
First, take a pint-sized plastic bag. Okay, so then add 1 cup of half and half. Two tablespoons of sugar. And 1/2 teaspoon of vanilla extract. Okay. Seal the bag tightly, trying to get out as much air as possible. So, once you get as much air out as possible and seal your bag tightly, double bag it by placing it in another pint-sized Ziploc bag for security. Now take a gallon-sized plastic bag, fill it about half full with ice, and then add a 1/2 cup of salt. Any salt is fine. If you have rock salt, it's better, but table salt is also perfect. So now we shake it to distribute the salt. And ice evenly, and then, okay, we add our ice cream into the bag. Seal it tightly and shake until the ice cream begins to feel firm. So while Amon is shaking the ice cream, let's talk about the science behind what we just did. So you might be wondering, if ice cream has water-based ingredients in it, like milk, why isn't it hard like an ice cube? Well, let's look first at plain old water. A water molecule is made up of 2 small hydrogen atoms and 1 larger oxygen atom. This is why water is known by the chemical formula H2O. Now, the oxygen atom in water is much more electronegative than the hydrogens because it likes to draw negatively charged electrons toward it. This gives water a positive end near the hydrogens and a negative end near the oxygen. This unequal sharing of electrons is known as a dipole. Negatives attract, and so molecules with dipoles like to form a very organized pattern. Water, in particular, can experience something known as hydrogen bonding. This is a type of force between water molecules where the positive hydrogen atoms place themselves near the negative oxygens in a pattern-like fashion. Because of this special property, when water freezes, the molecules behave in a very specific way to form a very specific crystalline structure, which we commonly know as its solid form, ice. So why doesn't ice cream behave like this? Well, ice cream has a bunch of fatty molecules that look something like this. These molecules interrupt the water molecules' interactions with one another, preventing the formation of hydrogen bonds. Now large chunks of ice can no longer form because we have all these long random fatty molecules in the middle. But now you might be wondering, if we have these fatty acids, why does Amon have to keep shaking the ice cream for forever? Why can't we just mix it and stick it in the freezer? Well, there are 2 main reasons we might want to shake the ice cream. Reason number 1, by shaking our ice cream, we are constantly trapping air molecules in it. In fact, ice cream can be 20 to 50% air. This is why ice cream is so fluffy and soft. Reason number 2, shaking also prevents the fatty molecules from clumping together and forces them to mix with the water. The fewer fat molecules that clump together, the more we have to stop water molecules from freezing into larger chunks of ice. This is why you might have noticed that if you take an ice cream carton out of the freezer at home, let it melt for a bit, and then put it back in, the next day you see large ice crystals on top that make it really hard to scoop the ice cream out. And finally, why did we have to add salt to the ice? Adding salt leads to an effect that we call melting point depression. So what exactly is this magical phenomenon anyway? Well, let's look at normal salt-free ice. If we leave it out at room temperature, The ice will slowly warm up over time until it finally reaches its melting point and then becomes a liquid. However, if we add salt, this melting point is actually lower and the ice melts more quickly. Now we need heat. So where does this heat come from? The ice cream. So the more quickly the ice melts, the faster your ice cream solidifies and the less time you need to spend shaking it. So now that Aman has finished shaking the ice cream, let's take a look at our finished product. As you can see, the ice cream is now hard and ready for eating. At this point, you can also customize your ice cream with your favorite flavors and ingredients like Oreos.